G'day everybody. Hope everyone can hear me. We should probably have some people on channels. Okay, cool. I think let's kick it off. Mitch.
Do you want me to run the slides?
Yes, can you please run the slides? And then what I will do is, yeah, I can just kind of talk through the slides. I've got my own notes here on the other screen. And then we'll kind of when I go into demos, I'll just go ahead and share my screen because I've got a few demos. So we'll get started. G'day everybody and welcome to the Brisbane Infrastructure DevOps User Group. My name's Michael. I'm one of the leaders. I should say leader, facilitator. That's probably a better word. Loose associate. Along those lines. So welcome to this month's talk, which is about PowerShell Security, Script Security Part 1. I could jam the entire suite into it, but we will be either going way over or we're just not going to be covering key content. So I think what I might do is over the rest of this year, we just kind of let it slowly come out with different parts of it. So let's get started. We might as well kick off the slide deck. Yep, cool beans. Alrighty. So I just might as well go to the next slide. That's actually something we're going to have a talk about. We'll talk about that later. I'll talk to Mitch about that. So yeah, huge thank you to our sponsors, Hudson and ScriptRunner. If you're not aware, ScriptRunner is basically a PowerShell script execution platform that enables you to be able to execute PowerShell in your environment without having to abstracting away the complexity of PowerShell and making it available to your normal everyday users. Really great tool. I'm actually playing with it at the moment, and I'm trying to do stuff, push it to the limit with desired state configuration. It's really great tool. If you want to kind of let help desk want to run some scripts and without them killing your environment, think ScriptRunner. The next one, obviously, we'll quickly go back a quick slide. The second one is Hudson. So Hudson's a recruitment agency. The boys of Pablo and Victor, absolute champs, really great people. Yeah, if you want to think about going and get a job, go talk to Hudson. They're really good. I vouch for them. Now, let's go on to our next next slide, which is leadership changes. So, I think what's going to happen is, so this month, Wayne's basically decided that he needs to spend a little bit more time focusing on work. If I believe, you can fill me in, Wayne. Or feel free to interrupt, or
no, I was spread too thin. That was my problem.
Yeah. Wayne will be stepping down as a leader. He'll still be rocking up to the user groups occasionally, and he'll also be occasionally presenting. That's just a bit of a notification for everyone. So any comments or any stuff you want to mention, Wayne?
No, that's good.
No. Okay, cool. Cool. All right, let's move on. Leadership. Oh, so no, not that one. Yep. Next up in June, so Modern DevOps on AWS. So that's our next meetup in June. So AWS will be coming and actually presenting a talk. So that'll be really good. It means that I don't have to think about writing stuff. So that's always great. So I'm really interested in seeing what they're kind of doing within the DevOps space and within AWS. I haven't seen a lot of AWS lately, so this will be really good. I haven't actually included any news, so I'll just quickly throw it out there. Has anyone got any news that they want to talk about within the PowerShell space, DevOps, Python, any sort of thing that they want to raise? Feel free to jump in.
Well, it was Microsoft Build recently, so I could spend the next hour telling you what's new in the Microsoft Cloud, but we haven't got time for that.
Yeah, a lot of new stuff, basically.
Yeah, I have a feed in Slack that tells me every new Microsoft announcement that comes up. I came to Slack the following morning after Build's keynote, and there was 80 messages in the channel. I'm like, yeah, okay. I'm not going to cover all that.
All right. All right, we might as well kick on. So obviously the main talk today is PowerShell Security Part 1, Script Security. So I'll just quickly go to the next slide, Mitch. I've got a couple of, I'm going to try, a little bit about me. I'm a Microsoft MVP in Cloud and Data Center. I've done PowerShell since 2013. I'm a PowerShell developer. I do streaming on Twitch. You can catch me on Twitter. I am occasionally on Reddit answering questions. And yep, that's pretty much that. I have a cat. That's probably my personal antidote to that. So now let's quickly talk about PowerShell Security. We're going to kind of get started. We've got a little, I don't want to take this too long, but we'll try and keep this short and sweet. So the first thing I want to talk about before we kind of go right into the weeds, we kind of talk about the PowerShell Security Diamond. This is kind of a coin that I've kind of come up with. I don't know. There's probably someone else's. Microsoft's probably come up with it, but I just haven't come across it yet. So, but the whole concept of PowerShell Security is that it needs to be factored. It needs to kind of sit into 4 areas. There's kind of 4 distinct places where security elements, we'll call them elements, essentially that need to be kind of defined to be able to actually properly secure your environment. I kind of lean on, I kind of say to people, or say, hey, if you are going to, want to go down this path and really go, and implement the entire, implement the suite, you really do need to implement all of it. It's not, and the reason why is that there's a lot of things that are kind of loosely integrated within each of those kinds of different elements there. So script does integrate with execution and remoting, and then basically, script executes within execution, and then you obviously got console and execution are kind of bound together, and remoting also is a key area as well. The key thing here is that it's one of those things you can implement incrementally, but you don't really get full coverage until you actually have all of it. The key thing, the other thing is that I've heard people saying, hey, I have script signing implemented. That's great. I have constrained language mode implemented in my organization. That's great. But that's all they have. It's good. It's a good start, but it's not going to give you full coverage against everything. There's still plenty of things that any sort of attacker can do within that environment. So it's really one of those things you have to consider all 4 of those elements and make sure and kind of look at a means to be able to implement that as a complete package. Alrighty. So let's talk about part 1. We're just going to basically 3 simple things that I kind of think that are really, really quite easy. Oh, sorry, Mitch, next slide, please. Next slide. So talk about 3 simple things that really, really help with PowerShell security straight off the bat when it comes to your code. And these 3 things these are essentially can be expanded on in the subsequent talks, but essentially the key things that we're going to be looking at is password credential management, script signing, and code review with PS Script Analyzer. I'm just going to quickly throw a quick hands up question. You can kind of just throw it in chat and stream. Who here is using secrets management in PowerShell for their credential storage? Just quickly throw a chat. Bit of a terrible poll. I didn't actually. I'm literally making that up on the spot. So it's one of these things that you kind of use it, you kind of don't use it. I've seen it implemented in my code. I've seen it implemented, not implemented in my code. It's one of those things that, Now, one of the things that we're going to kind of talk about is the different kinds of areas of credential management. Sorry, I'm just going to quickly. Okay, sorry, I'm just kind of catching up on the slide. So we're going to talk a little bit, so within the credential management. So there's a different variety in terms of scope of what you can do within it. So I'm just going to go ahead and share my screen now. I'm just going to quickly chuck that up, quickly zoom in, make sure I'm actually sharing. Let me know when you can see my screen. That is which one is it? It's this one. Just let me know when you guys can see that.
Yep.
Okay, perfect. All right, so I'm just going to zoom that in so everyone can really see it. I'm just going to kind of scroll up to the top here. I'm going to just minimize this a bit. So I'm going to quickly make a quick disclaimer about secure string. Microsoft have deprecated it. I don't really know what's going on with it in terms of this as a viable solution. I feel like it's kind of fallen into a bit of a black box of it's going to be replaced, but then there's not really much there. I know I spoke to Jordan about it. Jordan's it's kind of a bit of an unknown at the moment. It's a little bit like sending a message. So there's two kinds. Okay, so there's two types of ways that I see credentials being implemented in environments. You're generally going to see your static secure strings, or you're going to basically see PS credentials. The PS credentials are essentially just a wrapper for secure strings. It's just basically a means of being able to actually contain an identity with that. So as a secure string, it's literally just a static string that's basically being encrypted by the Windows Data Protection API using the user context, where the PS credential obviously has that kind of... oh, look at that. That it actually has that it can store an identity. And as you can see within here, if we basically go ahead and execute this is pretty simple stuff, so I'm not going to spend too much time on it. You can see here that you can see the username being returned, and then you can see the secure string. Now, this is one of the interesting things, is that because it's been encrypted with the Windows Data Protection API with the user context, we can decrypt it. So it's very similar to your kind of, it's nothing's going to ever be secure, because at the end of the day, though, it's executable code. It just means that it's not going to be visible to the pipeline. So if this basically a secure string was running, you're not going to see any sort of string being out, like any passwords leaking out into your pipelines or even into your log files and things like that. Let's go ahead and grab that function. So I'm just going to go ahead and execute this. And so essentially what that function does is it just uses the Windows Data Protection API to convert it. And what we're going to do is we're going to convert it. So we can actually go, let's just go and grab the secure string. We're going to break every rule under the sun, and we're going to convert 123 password to a secure string in the way that we're not supposed to. But this is just kind of going to demo the fact that we can decrypt it. So you can see here, when we run it, we can decrypt it. I'm just going to minimize, actually, I'm just going to drag you up Wayne there, so the Teams window. So that's, that there's nothing really special about that with regards to any sort of security there. I think most people know that, that it's not absolute. It's basically within the user context. Like I said before, please, for the love of God, let's not use this. This is the biggest gotcha. If people are going to go look through your code and go and look for passwords, and they see things like this in there, that's an easy given. So let's not do that. That's a really, that's not a good way to do it. But what I can say is there's a better way to do it. But before that, I want to quickly talk about web API headers, or any sort of thing where you don't have the choice and a password has to be presented as a string. So what do we do here? Now, I'm going to be using invoke REST method in this instance as a demo. Invoke REST method in PowerShell 7, they support, it supports essentially the credential being passed as a secure string, so you're not having any sort of leakage outside of that. However, in 5.1, you don't really have that capability to do that. So what the best thing you can do is essentially abstract, is to create essentially a proxy function which will accept a secure string, and then you do your conversion within there. The idea is that you want to take it all the way down to the very last invocation of your commandlet, execution of your commandlet, then you do the decryption. If that's a choice that you don't have. The idea there is that you want to keep it as secure along your entire PowerShell script right to that very end, and then you can then execute what you need to do. That way, there's less chances of passwords leaking out. It just means that you also you can parameterize your input to your scripts or whatever. You can still use credentials or secrets along those lines. It just means that you can ensure that there's no chance, for whatever reason, by accident, or if that's it leaking out into some sort of log or into the output pipeline. There's other ways to secure your auth, and I'm going to talk about CliXML. So I'm a massive fan of CliXML. This thing is a bit of a catch-22. So I'm going to talk about PowerShell data management quickly, and then I'm going to talk about a little bit more about CliXML. So if you're not familiar with CliXML, Microsoft essentially recommend, when it comes to data storage and retention, if you're using simple objects or simple lists, when I mean simple objects, I mean singular object with properties, use CSV. That's a really great way to store data. If you're basically using anything more complicated than that, so you have nested objects within lists, things like that, actually, kind of stretching CSV's capabilities to be able to retain that information, Microsoft recommends to use CliXML. Now, one of the things about CliXML is that CliXML essentially it's a loose representation of a PowerShell object that you're exporting as. So it essentially deserializes and serializes as an XML type, but what it's doing is it also provides kind of object type data about that specific object that you're exporting, so it can kind of retain somewhat of the somewhat of the object property structure. Fun fact as well is CliXML is what's used in PowerShell remoting as the transport medium, as I found out with doing a deep dive into that. Now, one thing about CliXML, and this is actually a feature as well as I'm going to say a bug, but an annoyance is probably the better word, is that it will automatically encrypt your secure strings. So if you export to CliXML a secure string, it will encrypt it. So what we can do here is let's go ahead and do that. So I'm just going to create a standard PS object. We're going to break every rule in the book again, and we're going to basically convert that property to a secure string. So you can see in here we got our property and our secure string. What I'm going to do is just make sure that I'm in the right. I'm just going to pop this on D drive, D10. We're just going to go ahead and export that XML. So, and before we go back in and try and import it and do all this extra funky stuff, what I'm going to do is I'm just going to jump into D drive. I'm just going to jump into a different. What do I call it? Export. Let's open it up for everybody to kind of have a quick looky-loo in here. So as you can see in here, we have the CliXML file, and you can see here that's basically containing type, that loose type information that I was talking about. The other thing which you can see is that we can see our property here, and then we can, the property called property, really not good naming for my part, and then we have the value of that property. And then you can see here we have the property secure string, and we actually have a secure string after that. So the password has been encrypted within CliXML. So we can go ahead and import that. There's no issues with that. So let's go ahead and do that. And you can see here all the contents retained. But now I'm going to throw a spanner in the works, and I'm going to show you what happens when we do it in Windows Sandbox. Now, if you're not familiar, Windows Sandbox is a great quick virtualization environment if you need to spin up and destroy content quickly. So I highly recommend it if you're just kind of needing to do some testing or something, and you kind of just want to have a quick environment. You don't really care about it, and you can just spin it up and throw it, then bin it. So what we're going to do is paste. And we've got our CliXML file here, so I'm going to just go ahead and open PowerShell. I'm going to try and open PowerShell. So we're just going to open Windows PowerShell. That's fine. So it's going to go ahead and copy as path, and we're going to go and try and import that. Import by XML, little path. Oops. And you can see here, it basically, we get an error that gets thrown. Key's not valid for use in specified state. And the reason why is because the CLI XML couldn't deserialize, or couldn't decrypt that password because it's on a different user context. And this is the big gotcha when it comes to using the Windows data, the DAPI, the data protection API, with the user context, is that that string is only secure with that. Now, this does present issues, especially when you're trying to deal with things like, hey, I'm going to hand it, like I'm doing a large amount of data work, kind of written some code in there. It's exporting properties, and you've got passwords in there. Let's say you're trying to generate, you've got a list of passwords in there that you want to generate. Those passwords essentially only going to be made available for your user context. Anything else, it's just not going to work. So that's a massive gotcha. And that's one of the reasons why CLI XML is not a good solution for it. That also raises the question, try not to store secure strings in CLI XML, because out of the box natively, it won't actually serialize it. So that means that your scripts will fail just trying to import it. It won't ignore it. It will just flat out fail. All right. So let's talk about PowerShell Secrets module. Essentially, it's just a module architecture that's used for managing passwords. It's basically, it's an open source product that essentially they provide the documentation for you to write your own store, in which basically it kind of just connects into. I've got a really good slide, actually, Mitch. If you could share your screen, I'll stop sharing. I've stolen a slide from Mike K, and I'm just going to quickly talk over it because I think it really describes the architecture of it. So as you can see here on the left-hand side, we have our console. That is obviously, our end user. That's the recipient. The Microsoft Secrets Management module kind of sits in between, and then each of these kinds of just wait for that. Each of these let's say LastPass modules, secret modules, or stores, they're essentially independent PowerShell modules that effectively interface with the Secrets Management module. The Secrets Management module just provides a common set of commandlets that you can use that basically work across different modules. So it makes it really, really easy to save and store your passwords. And I'm going to show you how. Alrighty, so what I'm going to do is I'm just going back to share my screen. Does anyone have any questions at the moment? Hey, Shane. I just saw you just said, hey, g'day. Sorry, mate. All right, we'll just quickly carry on. Is there any questions? I don't see any questions in the in that. So, okay. So we'll quickly talk about, I'll just quickly go back and share my screen, and we'll go through, keep cracking on. So, Secrets Management. So to install it, I'm just going to go straight down. You just install the Secrets Management module, and then basically you can install your secret stores from that. Now, I actually haven't installed any of this. I've installed the Secrets Management module, but I haven't installed the store, so hopefully my demo's going to be good. But the first thing I want to kind of talk about is we'll kind of look at how it works a little bit, and then we can kind of go from there. So, like I said, we've kind of used the we're going to use the KeyPass as our secret management store here, and we're just going to set up some parameters here to be able to connect to it. And first thing we need to do is we need to register our vault. So this is again common. You can register multiple vaults. It's not limited to just one vault, so you can don't worry about that warning. That's just me being me. I've just got other things happening. So yeah, essentially you can have multiple vaults, and you can essentially address, and they can be obviously from different types. So it's not, you're not just being locked into a specific type. So you can have KeyPass, Key Vault. I know that there's like LastPass. I think there's AWS ones as well, and it's obviously because it's open source. You can even just write your own if you really, really want to. So let's go ahead and go and register it. And so I've already set up a, you can see down here, I've set up a link, and I've actually already got a key pass file set up here. And we can actually go ahead, actually before we do that, let's actually go and have a quick look at it. So you can see that it's present. Let me just quickly go and find it. Sessions 2022. May. Okay, I'm just going to have to open KeyPass, 2 secs. I use this as my daily driver, so it's just got to quickly take it off the screen for a sec. Okay, cool. All right, so you see here I've got to log in. I think the password's 123 password. I hope it is. I haven't changed it. Okay, cool. So we're in. So you can see here we're in Key Vault, and I've got a couple of entries in here. I've got sample entry and sample entry 2 in here. We're going to do the same thing. So as you guys are going to expect, we're going to register it. So we're going to go ahead and register our secret vault. And once we've registered our secret vault, we can actually go and get some secret info. So we're going to go run that. Now you can see I've got to authenticate. It's going to go to 3 password. And you can see here it's returned our entries. Now, the interesting thing here is you can see that the type that it's returned is a PS credential. And this is one of the cool things about it is that you can, depending on it, you can obviously, the secret, you can have secure string or it can be a credential. And because this is a credential, because you have a username and password, it's going to be a credential, which is really quite, it's, obviously the architecture of it. And so, yeah, and obviously we can unregister the vault. We can go ahead and go and get a secret. So let's go and get a secret, get secret. We can just go name, and we're just going to go sample. And I really should have called this something better than that. And you can see here, we then have our credential. Let's go that. And then, as any sort of PS credential, the password then is encrypted as a secure string. So again, that's that whole concept of abstracting away from the pipeline and keeping it secure wherever you need to have it. And then, like I said before, if you need to decrypt it, you decrypt it at the very last moment. We can go ahead and have a look at the password so we know that it's legit. So obviously we can just go convert to plain text. Convert to plain text. Convert to plain. Is it? This is it's because I haven't run it yet. And then we can go convert to plain text, and you can see there's the password. So that's pretty straightforward. It also applies with Key Vault. So I'm just going to have a quick look at Azure Key Vault here. I'm going to go ahead and install these. Go ahead and install those. And while we're waiting on that, I'll quickly just show you we've got a secret set up in Key Vault here. This is probably the easier way of doing it. This is the way that I'd recommend people to do it. It's just, stick them in Key Vault. And like Wayne basically said earlier, is that you can obviously set identities based on this and policies around this. So, different identities don't have access to the entire suite of secrets. And obviously there's, and if you're not familiar with Key Vault, there's tons of really cool features in here. You can set basically expirations and rollovers and things like that. So it's a really, really good password management tool. So let's just wait for this to install. Does anyone have any questions while waiting for it to install?
There's a little bit of a discussion going on about, how you do that initial authentication to unlock your vault.
Yeah, so that's actually something that there's a couple of ways you can get it. There's a couple of ways you can get around it. You can disable it, so there is no authentication. That's you have to use clear. Essentially, you have to use clear secret vault, and then you basically have to set the vault. you have to reset the vault with specific parameters. I can't remember the exact thing, but you can do it. It is possible. I think someone actually talked about it on Reddit a couple of weeks ago. So if you search on Reddit under the PowerShell forum, you most likely will find it. So I'll quickly keep cracking on. So again, it's the same kind of thing. Now, one of the things I quickly wanted to talk about is that the some of the parameters. And you can see here when we're registering the secret vault, you can see that you have to specify the module name. So that is going to be the module name of the key vault. So if I drag this down, you can see there it's AZ key vault. Whoops. AZ key vault. It's basically essentially just importing that module, and what it's doing is just kind of importing the module and kind of with those parameters. And you can see here, we basically need to just specify the vault name, and we're going to need to specify the subscription ID of our tenant of our tenancy. Yes. So, and that's pretty much that. So again, go ahead and invoke it. Oops, we better. Actually, we're going to need to unregister our vault. I'll just quickly go ahead and unregister it. You can use a different name, so I can basically call it like Azure Key Vault along those lines there. But I'll just kind of keep this simple so I don't have any sort of issues. And now let's do the same thing. So we can go and get secret info, and you can see here. Oh yeah, no current vault extensions registered. At least one of us registered secrets. Okay. So did I actually run that? I didn't think I did. Let's try it again. Okay, so that's now hopefully worked this time. It's either going to ask, I think it's going to ask for authentication. So yeah, you can see here now I need to actually connect to Azure. So I'm guessing, yeah, hang on. So let me just quickly do this. So now if you already have that authentication set up, whether that's through all the different authentication mechanisms within Azure where you're using manage identity, the way that I would do it, and Wayne kind of demoed this earlier, was that you could use the managed identity of the machine within Azure Arc to authenticate to Azure, and then basically retrieve the key that way. So that would probably be the better way to do it without having to actually input any sort of username or password. Correct me if I'm wrong, Wayne.
No, that's definitely the way to do it, yeah. And then you can assign access to the secrets very granularly with Azure RBAC. So you can say this machine can have access to this secret. And you can even say this machine can have access to this secret until this time if you want to as well.
So Shane raised the question, would this work with MFA, or is there a workaround? So this is really that answering that question, where it's essentially you would authenticate as an identity. Alrighty, so let's go and get some secret info. So we can go ahead and now run it. How easy is that? It's so good. It's just like, hey, here's your secret. And obviously we can go and get information about that. So let's actually just chuck that in a variable and go and have a look inside it. Let's see what's in here. We could run get member.
Just another thing quickly, Michael, on that question about the MFA is another option would be to use a service principal in Azure AD, and then use a like a password secret for that credential that gets you around MFA in Azure.
Yep.
Like an application secret that you can use as a password.
Yeah. So so you can see in here where we've obviously got our secret info. We can't actually see any sort of information about it. One thing I really want to draw your attention to is metadata. So you can actually store metadata about that secret within there. So and that's really handy when you're kind of trying to do extra, you need to store a little bit of extra information about that specific authentication. And, whether if it's in a DevOps pipeline, that could be a URL endpoint or something that you need to you don't particularly want to have to put it in a variable or something, but, it's kind of associated to that credential. So that would be a really good, an example of that. So, and you can see here, obviously we have a whole bunch of info. We can now go and get that password. And again, it's a secure string. So T2 plain text. And you can see there, we basically have that password returned. So like I said, again, you shouldn't be doing this. You should be converting to plain text, keep it a secure string. Only time you should be doing that is if you're not if you have to, keep it as a secure string all the way through until you need to execute, then convert it to plain text and put it in the function that requires plain text. Otherwise, use credentials. So let's go ahead and unregister it. Oh, look at that. Or it's kind of just talking about this. So I think that's pretty much that. I'm not going to really, that's pretty much credential management. I'm going to talk a couple of bit about best practices. So I'm going to stop sharing. I'll get Mitch to throw up a the slides. Mitch and Wayne, your video has stopped, it looks like. Oh, cool, you're back. Cool. So we'll go to the next slide. And this is kind of 4 points that I just want to talk about in terms of best practices. Oh, look, it's actually animated. I never even knew that. So we'll just, keep going. All right, cool. So these are fairly straightforward. I've kind of explained through them, so I'm just going to reiterate them. So your best practices are use PowerShell Secrets Management. That should be your primary port of call. Always try and use Secrets Management. Try and use XML otherwise as to store passwords. Like I said before, if you're forced to use plain text, parse as a credential or a secure string and then decrypt prior to invocation. The idea there is that, again, we're just trying to prevent that leakage to the pipeline. And the final thing here is, for the love of God, no plain text passwords. And I've seen this over and over again. I think that, that kind of just speaks to itself, and obviously, we don't particularly, I don't think there's really anything else to add there. Let's kind of crack on. I've got a fair bit of other stuff to talk about. So, code integrity with PS Script Analyzer. I'll just quickly throw it out there. Who knows about PS Script Analyzer? I know there's a few people out there that will probably know it. So, PS Script Analyzer is awesome. It's a really, really great tool. Now, before I talk about PS Script Analyzer, I'll just quickly go to the next slide. I want to talk a little bit about what is the PowerShell AEST, or the abstract syntax tree. So essentially, it's a syntax representation of PowerShell tokens that are parsed and then are grouped into different AEST types. The idea is that it's kind of just essentially a programmatic structure of representing your execution. It's broken down into different object types of different things. So tokens could be variables. They can be different. They can be script blocks. They can be I'm just having memory blank. Jordan will be able to answer this. I'll add a lot more here to that. But the idea is that it's just a representation of that. And because we have the AEST, and most programming languages have some sort of abstract syntax tree, we can actually use that to analyze code. Now, let's go back forward and let's talk about PS Script Analyzer. So, PS Script Analyzer essentially is used as a static code checker for PowerShell scripts and modules. If you're not familiar with it, it's really used in a way to be able to kind of enforce coding standards, kind of things along, and it will report issues when things don't meet those requirements. So, for instance, if it says a person's using trap, is using statements that you kind of want to weed out in your environment or even in your code, it's a really, really great way to kind of use that. And so you can essentially write a thumbprint to look for that, essentially as a regex string, and then it will be able to, and actually it's to be honest, it's a regex string, but you can kind of make it whatever you want, to be honest. And then you can use that to be able to report on any sort of issues within that. Now, out of the box, PS Script Analyzer has a whole bunch of cool stuff. In terms of you can basically use it to run, checking for spaces, variables that haven't been used, those kinds of common linting things. PS Script Analyzer is an excellent tool used for actually checking for security as well. So you can just basically jump on, install the module PS Script Analyzer. Super easy to use. It requires a little bit of it's a little bit of a learning curve to try and get your head around, but once you kind of get the hang of it, and you can kind of it's really quite handy. One of the things I did with it in a previous role was to actually weed out a lot of scripts that basically had a dollar error pipe out string. Dollar error pipe out file as a means of logging, and we kind of needed to find out everything out there in the wild to try and to get a bit of an idea of what's in there. So rather than having to open the script or kind of doing a control find, you can just kind of send this one out, and you can target paths, and it's really quite powerful tool. Alrighty, so I'm just going to go ahead and back into demo land. So I'm just going to go ahead and share my screen. So PS Script Analyzer. So one thing I quickly want to, before we do anything, I'm just going to show you what it looks like in action. So you guys get a bit of you can familiarize yourself with it. So what I've got here is I've got a script that's just kind of off the screen. And we just basically, let's just go to PS Analyzer script. I'm doing some really naughty stuff here. So what we're going to do is we're just going to basically run it and see what happens here, and you can kind of get a bit of an idea of what we can do with it. So when we run this code, you can see here, if I just push this up, sorry, let me just clear that. Why this is now broken? So let me try that again. All right, so you can see here, we can invoke a command, and it gives you a whole bunch of cool information back. And essentially, it gives you an object that gives you an explanation of what's going on. You can see here, users convert to secure string with plain text. This will explain secure information. So out of the box, you're already getting this good stuff. Avoid using right host. Yeah, and then you can see here, we've got some other things in here. So like, the variable password's been assigned and never used. If you're using Visual Studio Code, it actually uses PS Script Analyzer under the hood. So it's actually a, just going to close everything to the right here. So you can actually see stuff in linting prior to it being, actually having to run your script as well. So it's really quite handy. PS Script Analyzer supports path-based execution, so I'm just going to minimize that. So you can see in here, we're not targeting a single file. You can target a path, and you can see I'm just going to use a reverse parameter. And I'm just going to target all the scripts in this directory, which is a bad idea because there's a lot of bad code in there. And you can see it's coming back and it's saying, hey, these are the kinds of issues that we're having. You can be very verbose with what kind of errors that you want to look for within PS Script Analyzer. So you can go invoke Script Analyzer, and you can basically say what kind of rules you want to use, and the rules are essentially what is being used on the left hand side. So you can say, hey, I'm looking for everything that's, I'm looking for all the peer, right hosts within my code, and you just basically target it using that. The other thing which is really cool, so we can go ahead and we can narrow it down to the severity as well. So we only want to target error. So let's go ahead and run that. And you can see here it comes back immediately, and the first thing that we have is a big issue, a red flag with the secure string to plain text. So that's PS Script Analyzer. It's a really great tool, and you can see that, and there's tons of rules that we have there. So we can go ahead. Actually, we'll quickly jump into this one first before we talk about pest to test. So you can see in here that essentially out of the box, you have a whole bunch of rules that you have available to you. And this can be, and like I said, this is completely open source. So you can write your own rules, which makes it really cool. The other thing is as well that we can integrate this in our tests. So I've just written a really basic pest to test here. And you can see here that essentially we can invoke our PS Script Analyzer, and we're expecting that there should be no results that contain an error. So let's go ahead and run that test. Hopefully there should be any issues. And you can see here that we have a test failure because, actually no, it's because it doesn't exist. Let me just quickly fix that PS Script Analyzer. Okay, so let's go ahead and rerun that. What am I getting wrong here? B is not a valid. you know why. This is because I haven't installed the latest version of Pesta. So this is a Pesta version 5 test. So I'm just going to quickly install Pesta v5. While we're waiting on that, we just quickly carry on and then I'll come back to that demo. So the other thing which you can do is we can write suppressions in our code. And what I mean, essentially you want to be able to suppress specific things in code that you don't particularly have to, that you don't really want to be flagged because of specific things. Force parameter. Okay. Force. I think I'm going to have to use no combo as well. So yeah, it's you can essentially suppress by defining using the specific object type, and you can basically insert it where you want to have the code suppressed. One key thing here is that you can't use wildcards. So if I quickly show you, for example, if we go and use wildcards, suppression example 2. So if I kind of, no, that's, yeah, it's always the one above. So if I kind of use any sort of wildcards, it's just not going to work. It'll fail. It's explicit. So essentially you have to, define what kind of rules that you want to suppress. And it's essentially, it has to be, and essentially it has to be before your parameter block, and then you can essentially run it. So what I'm going to quickly do is we'll jump back into the previous test. We should be able to actually run this now, hopefully. There we go. And you, yeah, okay, perfect. So you can see here that we've run that test and now we've got an error. And you can obviously be a lot more verbose about how you want to do this, but this is just kind of an example. We can integrate our security analysis into unit testing. So you can essentially put some sort of code analysis within your DevOps pipeline if you need to be able to kind of make sure that there's no shenanigans happening. Let's jump back into suppressions. So I'm just going to quickly we'll just quickly jump back into the first suppression. So so when we define it, essentially, like I said, we talk about the actual rule, and then we can give it a justification. And so the justification will be, you explaining why that we need to suppress it. So in this instance, I'm just saying this is just an example. So we're going to go ahead and run that. And you can see here, we've suppressed avoid using right host. And even though we're using right host in our code, it's suppressed it. Which is great. And you can see here now we can just execute wildcards. Wildcards don't do anything. And you can see that it's still going to throw up a right host flag. Now, we can actually use scopes within this attribute. So by doing that, we can actually target specific functions. So you can see here what I'm going to, in this instance, this suppression is basically going to suppress all right host inside of function blocks. So you can see here we've got invoke something. This statement will be suppressed, but if the statement's outside that function block, outside of a function block, it won't be. It'll actually be flagged. You can take it even further, and you can actually target specific functions. So we can use the target parameter within this. And so we can basically say, all right, we're going to use a regex. This is a regex string. So we're going to basically say, all right, where anything that has invoke some and anything after the end, those statements will be suppressed as well. So you can see here, I'm not going to run this, but the idea is that this function, the statement's suppressed, this will be suppressed, but this function statement won't be suppressed because it doesn't meet that regex criteria. And obviously, the main block won't be suppressed either. So let's go and have a look at writing some custom rules. I think that's probably the next thing. And then I will link it back into security. So The way that we write rules essentially is functions available on the GitHub. If you go to the peer script analyzer GitHub, you can go and grab a template, and essentially it'll kind of bootstrap you and get you kicked in started. The whole concept here is that the parameter input essentially is just a script block AST type. So if you any sort of script block, whether that's a function, script. So, and when I mean script block, I mean it's basically curly brace, or that could be a script itself. It will accept that. As you can see, what we're going, I'm just going to quickly minimize this and jump into the main set of code. Just quickly. So the way that this kind of works is that essentially it uses the find all method to be able to find a predicate, which then you essentially is a this essentially is just a script block that we've defined, and so that will then go through the code and it'll go and look for, it'll execute with that that predictive will execute that script block, and then it'll basically, I can't remember what this, I just have in a memory blank. Yeah, actually, yeah, sorry. And the Boolean value that's after it is searching nested script blocks, which we want. We want to be able to search our entire, we want to search all our code. So in here, you can see it's a script block. Again, it's accepting an input parameter of the AST. So it's just basically passing the type in there, that type script block AST type. And then we're going to explicitly make our return value false. And then we can write our custom rules. So the first thing we can do is we can actually look at the definition. You can do type filtering on what you're wanting to get. So whether that's a variable, whether that's states, whether that's functions, statements, functions, those kinds of things to narrow your search. So you still have granular control over your logic here. So what we're going to do here is essentially we're going to introduce an additional filter saying if the members are part of a class, this rule only applies to bare functions, so no classes for us. So if the parent is a class, we're going to say nope. And then finally we can apply our filter. And basically it's if the underscore contains in the variable, if an underscore is found in the variable name, then we're going to return true. And essentially what we're doing there is just a simple regex match. And that's pretty much it. Like that's how it works. It takes, after it's found them, so you can see here the function, once it's, if the count is greater than 0, if it's not equal to 0, it will basically craft the specific object type, and it'll obviously just that specific property, those properties. So you can again, write your own. You can write your own messages within that. You can do whatever you want. So that's pretty much how we write our own. So I'm going to quickly just go and find. Oh, please tell me I didn't delete them. I hope I didn't. Just give me 2 secs, sorry. I'm just going to quickly go and have a look for some custom rules that I wrote in relation to security. Does anyone have any questions? No questions? Okay, cool. Sorry. Just bear with me for a sec. Sorry, I'm just trying to find find where I put these files. Okay, here's a good one. This is just kind of a loose example, but this is the kind of thing you can do with this. So let's just quickly paste this in here. Actually, I'm just going to reveal this Explorer. Apparently that didn't copy. So we're going to talk about the AMSI. Talk about the AMSI. So I've written this custom rule. Essentially, we have This is essentially a custom. Actually, this is not the PS script analyzer. This is actually an example piece of code of someone trying to bypass the MSI, and you can see here is it's doing some very low level content, low level stuff. I'm going to try and grab a PS script analyzer rule. Sorry, I'm just trying to find the rules. Example scripts. Okay, here we go. Here we go. Does this every time. Okay, so what we can do here is you can write custom rules. So let's say we want to block base 64 decoding. I don't know why, but this is just kind of an example I wanted to do. Essentially, we can write a detection rule. We can write a predictive to look for that specific line in code. So basically saying anything that basically has, from base 64 string along those lines, it's going to block execution. This one was actually quite hilarious to write because the AMSI was a PowerShell itself was preventing me from trying to do stuff with it. But essentially, you can, anything that contains the AMSI in there, you can block it. You can prevent memory patching. So you obviously want to, we're looking at the system.runtime interrupt surface marshalling class. And this is the kind of concept where you can really narrow, go down onto that. And it's essentially is how long is a piece of string in terms of what you're wanting to lock down. Obviously, like I said, you're looking for safe passwords, things along those lines. You can do things like, making sure that, credentials are being used. You don't see any sort of, you could even write, have a look at all your variables to make sure that there's no sort of weird variable names like passwords and things like that. So you can do a lot of analysis around that. Another one, which is another really good one, is kind of as an example. And this is one that I wrote just as another example. I'll just quickly chuck it in here. Is preventing PowerShell encoded execution. So people who basically, type PowerShell.exe and then actually try and, my regex is not great, but essentially trying to actually run PowerShell.exe, PowerShell.exe, and, along those lines. And the thing is that, and the really great thing about this whole thing is that you can essentially create your own module, which means you can write your own unit tests against it, and you can actually test to check what's happening there. So I'll quickly show an example here. Just your code. So you can see here, I'm going to say no PowerShell encoded execution. So, like standards string shouldn't return anything. We can basically go and test that. And then we can basically look for the condition E, and really kind of start, trying to make sure that what we're trying to do is essentially, bulletproof. And then obviously here now I'm just parameterizing my inputs. And that's pretty much that. So that's PS Script Analyzer. Does anyone have any questions along that? Any comments, queries?
So you're saying, Michael, that I guess it's use case, I suppose, because by default it's in things like VS Code, for general good practice. But you're saying, customize it for things like your pipelines, and where would you apply these rules? Like, at what point would you execute these checks?
It really depends where you want to. You can, so it. Well, you could, the way that I would do it is I would be putting it in my build pipeline and basically having tests to check it. Actually, no, yeah. So I would do it in the build pipeline or even in the code itself, where you have your code repository periodically going over the code, similar to what GitHub has, is where they have a bot going over looking for vulnerabilities. Those kinds of things you can do with your PowerShell coder.
You're sort of setting your standards. Like I could imagine this, like in my circumstance, being in your build pipeline. So when you do your pull request, it's you kind of get the results as you do other things.
That's exactly right. Yeah, and this thing, obviously, this kind of approach just really means that what code that you're writing is good code. So that aside, and obviously it's secure code as well. So you're not mucking around with, worrying about people doing the wrong thing or inadvertently doing the wrong thing in that circumstance. All right, let's keep cracking on. I'm going to jump onto the next part. I'll get you to share your screen again, Mitch, and we'll go to the next slide. Let's quickly jump on Twitch chat because I haven't been looking at that at the moment. No one's jumped in there. Cool. All right. So the next thing I want to talk about is PowerShell script signing. I know this kind of is one of these things that leads on into the next talk. But the idea here is that we're going to be using script signing as our means of code immutability within our organization. While script signing is essentially, people kind of loosely use script signing and associate to the PowerShell execution policies, it can also be applied to AppLocker and WDAC. So that's why this is actually a really great solution to be able to ensure that your code remains immutable within your organization. It also means that you can actually start to trust your code as well within there. So let's talk a little bit about script signing. So like I said just before, it's essentially the idea is that we want to have some sort of immutability, and we're going to be using code signing. Using code signing certificates, and then basically it can be used to enforce execution compliance within AppLocker and WDAC. And this is when I'm kind of talking about AppLocker and WDAC. Certificates is the best way to control your execution within your environment. There's essentially for a script rule, you have 3 rules. You have publisher, you have publisher, file hash, and path. Obviously, path is not good because anyone can modify the script within the path, and the code will still execute. Hash is annoying because essentially the policy has to be updated every time the file's being updated, because if it's changed for whatever reason, that's a new file hash. And then the final one is obviously publisher. And publisher is better because you can set the granularity on that specific publisher. So using a code signing certificate, we can basically say, we want to allow this publisher, and you don't have to worry about paths in that sense. So I see Wayne's deep in thought there. I'm just wondering, do you have any questions?
No, all good. Yeah,
Okay.
script sign. I remember doing script signing way back when, like PowerShell version 1 or 2.
Yep.
Yeah, it's really old.
It's very old. But the thing is that script signing works really well within AppLocker. So this is one of the reasons why, and that's the question this week. I was like, I'm pretty sure, but I just want to be 100% sure that I'm right. So I'm just going to jump back, share my screen, and we're going to go and have a talk about. We're going to look at some script signing. So let me just quickly close. Okay. Custom rules, script signing. So I don't have a CA set up. Actually, I should have set up a CA for this. The idea, we're going to be using self-signed certificates. The idea is to actually have certificates that are issued by a CA within your organization that you have authority over. Now, Active Directory Certificate Services is, obviously is a great tool. I know there are issues with it, but the whole idea is that you can actually, if you set up a process to be able to ensure that as the certificate is updated, those, actually, sorry, let me rephrase that. As your code's being deployed, it would automatically sign with that certificate. That certificate can get automatically updated when it expires. That then can be obviously, be updated in your code, which then can be deployed out again.
I would also just say, Michael, you can just purchase code signing certs from public CAs, and then you don't have to, if you don't want to deploy all of that.
Yeah, that's exactly right as well. And yeah, and you could just use signing. Or yeah, the other thing you can also do if you don't want to use the CAs, you can use Key Vault as well. They can you can obviously put certificates in there, but I don't think they're signed. I think they're just close. I think they're just self-signed. Correct me if I'm wrong, Wayne. So yeah. Anyway, that all aside, we're just going to go generate a certificate. So I'm going to go ahead and create my code signing certificate. We're going to use self. Oh god, that's a good start. Always love errors. Access denied. Okay, cool. All right, let's go ahead and rerun an admin. I'm just going to run this in the terminal. So we'll just quickly copy and paste this, and then we can jump back into. Oh my god, yes. Please run. So we can go ahead and create a certificate, and you can see here we're just going to be using a thumbprint. Obviously, every certificate has a thumbprint. That's pretty straightforward. And we're going to go have a look at that certificate. So you can obviously, you can use get child item to go and have a look at those certificates. It's probably not going to show up here, so I'm going to have to use it in here. Oh God, please don't tell me that it didn't work. It should have worked. Oh God, please don't. My demo. Where the hell is it now? Where did I put it? Oh, wait. Hang on a sec, sorry. I don't think, no, I think I've skipped a step because it hasn't been imported yet. Could be there. Can you just get something? Correct. Someone jump in if I'm like not doing something right here, but yeah, because I use self-sign certificate. Yes, let me just quickly.
Did it go into the user store rather than the machine store?
That's what I'm thinking. I'm going to quickly stick it there, and then go and have a look where it is. Local machine. Subject has extra my prefix. Subject has extra my prefix. Well, let's just have a quick look in. We should have 2 in there anyway. Okay. I'm just gonna have a quick look in here and see if there's any. Okay, they're there. So I've got 2 code signing certificates now. Where object filter script. Oh, it's probably because that should be fine.
I'm pretty sure there's a.
Oh no, Shane spotted
parameter.
Yeah, Shane has spotted it. It's the extra my. It's supposed to be there. There we go.
But I think there's also a dynamic parameter on get item and get child item where you can filter by code signing scripts.
Okay. Okay. I'm just. Okay, cool. Sorry, I just got lost for a second. Okay, yeah, that's cool. Okay. All right, so we can just go and grab the. Yep. So obviously we can go get the code signing certificate. We've got 2 now, but that's all right. So what I'm going to do is just select the first one. Get child item code. I'm just going to do the first one. Yeah, right there. You go, right there. I was like right on the next line. Select first one. So we can just go ahead and run that. You can see here we've got a code signing. So I'm just going to drop that into memory and we'll get a thumbprint. So now we're going to have to add it as a trusted publisher, and we're going to have to include it in our root CA because it's self-signed. So let's just go and do that. Just make sure. Actually, no, I've skipped a step. I'm just going to quickly export it. Give me 2 seconds because I've actually got a certificate already here. So it's going to see. We can just go ahead. I'm just going to delete one. So we having to write code to deal with that. So we're just going to go ahead and export it. Yes, please export the private key. Yes, we're going to use the super secure password. So we're just going to use A. And we're just going to pop it in that path. Just one moment. Just grab this path. Grab this path. All right, cool. All right, so we've now exported it into here. This is now the new certificate, and we're going to I'm just okay, cool. Yeah, now we've done that, we can actually go ahead and actually apply the signature to that. So I'm just going to make sure that path is correct. Actually, you know what? Oh, no, sorry about, no, sorry, no. Sorry, no, I just made a mistake. No, I didn't need to export it. This because we're just going to fetch the certificate thumbprint, and then we're basically just going to set the path. Sorry, I just for some reason thought I had to export it. Okay, so essentially we can then set our auth code signature. So this basically is a signing, a command that used for signing code, signing PowerShell code. And what we've got here is the path to our PowerShell script. So I'm just going to quickly jump into here, example scripts, and we've got unsigned scripts. So what I'm going to quickly do is create, just quickly make sure that, okay, we don't have one there. So we're going to go ahead and create an unsigned script. We're going to call it, sorry, cool. So we've got our unsigned script. So we've got our unsigned code. Now we can go ahead and code sign this. So the interesting thing here is you can see that it's failed. And the reason why it's failed is because it's not on the root CA. So give me 1 second. I need to actually add that into the root CA. So I did need to export it. I just didn't. I've just jumped in a step. 1 sec, sorry. We can go ahead and import it. Oh, don't tell me I just put it in the wrong spot. Nope. Okay, it's cool. It's there. All right. So if we go ahead and actually, is that the one? No, there it is. Sorry. So what we can do now is we can go and rerun that. Nope, not that, Michael. That. Please don't do this to me now. Let me just go ahead and restart the shell. Ah, so it's trusted publisher. It's in the root CA. Is it in the root?
It needs to go on the trusted publishers. So like the root CAs to verify the cert, but then you still need to trust the actual cert itself.
Yep, sorry. Cool. Put that password in. Yep, put it in there. Cool. So if we go ahead and rerun that, let's see if this works. What? Now why is it not working? Did I actually import it? Yes, I did. 2023. I'm just going to quickly check this one. Yay. Might just restart PowerShell. Actually, I can just jump in a different session. No provider was specified. What? That's not fun, is it? Why is that not working? That should have worked. It's a root publisher. Making sure that this is right. Trusted root. Yep. Trusted publisher. I'm going to run it in terminal and see if it's a PowerShell thing. I don't think it is. Okay, it is. So So essentially, we've now signed that PowerShell script. It's still called unsigned.ps1, but you can see here that we essentially have a signature block that's associated to it. One other thing which I really want to show is we're actually going to have a look at the file now. So if we actually go on, it's, let me just get rid of that. Get rid of that. Now I'm just going to rename it to sign because it's now signed. If we go and actually look at the properties, you can see here we actually have a digital signature available, and we can actually see the certificate. So this piece of code is now signed with the self-signed certificate. We can essentially now do stuff with it. With script execution policies, if I was to change this, so if we jump back into, let's just go ahead and let's go ahead and set our execution policy. This is not the be or end all. It's just kind of showing that, you know, obviously if PowerShell code won't run if we set it correctly. So if we actually call that code, PowerShell, you can see it says, unsigned code. But we're going to go ahead and change that, and we're going to then go ahead and rerun it. And you can see there's an error being thrown back. So it's essentially, obviously, this is just using script execution policies. In the next talk, we'll be talking a lot more about WDAC and App Locker and how it's implemented with that. But this is kind of just, you know, focusing on the initial script side of things. So that's pretty much it for this talk. It's gone on a little longer than I hoped it would have. Obviously, there's a couple of issues there, but yeah, that's pretty much it. Does anyone have any questions or anything? Looks like my Teams is frozen.
No, that was good, Michael. But I think code signing is one of those funny ones where it's like it's been around for so long and it's such an effective tool, and yet almost no one seems to use it. Even I don't use it. I'm just thinking, man, I really should be using that. I've already got code signing certificates out the wazoo for all this stuff I get devs to do, but I never actually utilize it myself. But it is like kind of hugely effective. It's like the first thing out the gate. Don't let something that's you don't trust run.
Paired with WDAC and App Locker, that is just, it's very, very powerful. It'll really lock down your endpoint. So I think it's one of those things that, like you said, go and buy a code sign certificate, go and, or if you set up your CA correctly, go and do that. The one thing that you need to do though, and this is something that is a big take home for everyone, if you're going down that path and you're signing your code, develop a process that basically does the code signing for you, whether that's, a separate DevOps pipeline. But the key thing is to keep track of what code or what scripts are being signed with what and where it's being deployed. So the idea is that when you actually need to go and renew, your code, you should be able to develop your pipeline in a way that code shouldn't, the certificate should never expire. So you should be able to deploy new code without it ever expiring, any sort of downtime. But the other thing is that you should be able to actually be able to identify very quickly what you have out in the wild, and be able to have some sort of governance around that. So, if there's a script that is a common script that's on 100 computers or 1,000 computers, that script's going to need to be updated, and you need to be, obviously be able to keep track of that as well. So, and that's that kind of process where, seeing that kind of change, you can go, okay, this, computer has the old version, and you can kind of make amends to that. And there's obviously configuration management solutions out there that will also help out with that. Sorry, Duncan, were you, did you wanted to say something? Sorry, I think someone wanted to say something. Does anyone have any other questions or anything? Just gonna quickly check chat. It's signed with self-time stamping. Yeah, I'm just gonna.
Yeah, the chat. I don't know what the chat's been like on Twitch, but the chat in the Teams channel has been pretty active all night, Michael.
Twitch has been very quiet. Shane's been it's been helping me out, but there's been a couple of people on. So yeah, I think if this so this is obviously part one. I'm going to slowly come out with the remaining of the parts over the next the later part of this year. So, and this is really, again, I'll be focusing on those other areas, and we'll be kind of drilling down into some very deep and dark areas of PowerShell, which I think, really help, especially around getting things like getting the implementation done right. So yeah. Anyway, that's it for tonight. Thank you everyone for joining. I'm going to go and stop recording and streaming. So thank you everyone, and yeah, I'll see you guys next time.